So now we've looked at all the basic shapes of graphs, it's time to see what we can do to them. We're going to transform some graphs today. So here are the 9 basic graph types that we should be familiar with, and this is what GCSE ultimately can test your knowledge of. So I'm going to jump straight in with the single most important point in this video, that transforming graphs, moving them around, stretching them, twisting them, has one rule, which is that if something is outside a bracket, you do exactly what it says to y values, and if something is inside the bracket, you do the opposite of what it says to the x values. Now I'm going to have that up on screen for the entirety of this video because it literally is as simple as remembering those two things and being able to apply them. So let's look at some examples of what I'm on about here. So these are equations of graphs, and they're similar to ones that we've seen before, but they've been changed a little bit. And we're going to use our graph transformations to draw them. So our first graph here is y equals x squared minus 7. Now what that's very similar to is y equals x squared. And we know the general shape of y equals x squared is that old smiley face positive quadratic. Now what's the transformation here? The transformation is that they've got this minus 7. Now look at that minus 7. Is that outside the bracket or inside the bracket? Well, there's no brackets to be seen, so it's clearly outside the bracket. So we'll do what it says to the y values. So what it says is minus 7 to the y values. In other words, we're going to move the graph down by 7. I'm going to subtract 7 from every y coordinate. So what would that do to my final sketch of what this looks like? We'd have the same shape, but it'd be 7 squares lower. So that's the basic idea. Now let's apply this to a few more. So our next graph, 3 to the minus x. What type of graph is this? This is an exponential graph. We know an exponential graph, roughly speaking, looks like that. What have they done? Well, the minus 7, or the minus x rather, is the thing that's changed. Is that happening inside a bracket? Yes it is, you can see the bracket there. So we're going to do the opposite of what that said to the x values. So instead of multiplying our x values by minus 1, we're going to divide our x values by minus 1. Now what will that actually do? That will reflect the graph in the y-axis, because all of the x coordinates that were positive will become negative and vice versa. So let's put that all together and think about what our final graph would look like here. Reflect that in the y-axis. It'll go looking something like that. Okay, let's look at another. 1 over and then bracket x plus 4. Which basic graph shape is this? This is basically 1 over x. What does 1 over x look like? It's that funky customer. Okay, what have we done different? Well, this is x plus 4 inside a bracket. Inside the bracket, do the opposite to the x values. So we're not going to add 4 to the x values, we're going to minus 4 to the x values. What's that going to do if we take away 4 from the x? Is it's going to move the graph left 4. So what would that look like if we did it? It would move left 4. Okay, that's it. So you get the idea here. If you can spot if stuff is inside or outside brackets, you know where it's going to go. You might want to try the next two yourself. Unpause when you're ready, but I'm going to go straight on with it. So this next one, that's got a cube in it. It's going to be like y equals x cubed. What does x cubed look like? Looks like that. What's the transformation? Well, it's a minus 2. Is it inside a bracket? Yes. So we do the opposite of that to our x values. We're going to plus 2 to the x values. What will that do? It will move the graph to the right this time by 2. So what would our final graph look like? It would look like that graph, but shifted 2 squares to the right. Okay, very last one here, y equals minus x squared. So that's going to be something like our quadratic, that's y equals x squared. Same as we started with a couple of graphs upwards. It's going to have a minus outside the bracket, so we'll do exactly what it says to the y values. So we're going to times the y values by minus 1. What will that actually do? Well, if we times them by minus 1, all the positive y values will become negative y values, and vice versa. So it will reflect in the x-axis. What would that look like? It would look like that. Okay, got a few more of these to look at. So, exact same idea. We're going to use the exact same rules. We're going to try with some different equations. Again, have a go at this first. See if you can figure out what's going on. And then we'll talk through them one by one. So unpause when you're ready. So our first one, the basic shape, is going to be y equals 1 over x. And that's the reciprocal graph. What's the transformation here? We've got a minus 4. Is it inside or outside a bracket? It's outside a bracket, so we'll do exactly what it says to the y values. So we're going to minus 4 to the y values. What will that do? That will move the graph down by 4. What would our final sketch look like? It would look like that graph, but 4 squares lower. Okay, what about the next one? Y equals minus 1 over x. So again, we are starting with the reciprocal graph. We are going to do exactly what it says because there's no bracket, so we're going to times the y values by minus 1. We've just run into one of those. What that does is it will reflect in the x-axis, because all the positive y values will become negative y values. What will that look like? Well, it'll look like we reflected it in the x-axis. So our positive values become negative and vice versa. What about the third one? That's an exponential graph to start with. Looks something like that. There's a plus 2 outside the bracket, so we'll do exactly what it says. We'll plus 2 to the y values. What is that going to do? It's going to move the graph up by 2. What would that mean we have? It means we have a graph that starts a little bit higher. Okay, 2 more. This is a quadratic, and we know a quadratic looks like that. Inside the bracket, so we'll do the opposite of plus 4, we will minus 4 to the x values. What will that do? It will move the graph left by 4. What would our final graph look like? Look like it's moved 4 to the left. Okay, one last one. What's the basic shape? This is an x cubed. That looks like that. Inside or outside the brackets? It's outside. So we're going to minus 5 to the y values. What's that going to do? That's going to move the graph down by 5. So what would our final thing look like? Like a cubic that goes through there at minus 5. So that's the basic idea. Now, this isn't the only way these questions can be asked. They can avoid writing down the equation of the graph overall, and you can just ask you what's happened to get from this graph to the other one. So if we're talking about going again from the graph and the arrow from f of x to this other one, what's actually happened there? Well, the graph has moved 2 to the right, so plus 2 to the x values. Now what does that mean? So inside the bracket, do the opposite of this. So inside our bracket, we are going to minus 2. So of our possible choices, this would be this one here. Now we're going to do a little bit of multiple choice now. 4 more of the same sort of question. I want you to apply that same sort of knowledge and see if you can answer them. Here's our next one, and here are our options. The difference between the two is obviously we've got -4 there and -8 there. Which one do you think it is? So the graph hasn't moved up or down because these points haven't moved. They're still at -2. So what's happened is the y values have been multiplied by 2. The graph's been made steeper. Now that's definitely something that's happened to the y values. So it should be outside the bracket, do what it says. We should have a 2 times outside a bracket. So our correct answer is 2fx. What about this one? Again, have a think about it. Here are your options. Now what's happened here is we've taken our -2, it's become -4, our 2 has become 4, all of the x values have been doubled. Now what does that mean? Inside the bracket, do the opposite to x values. So inside of our bracket, we're going to have to do the opposite of times 2, we're going to have to halve. So our answer is going to be half x. Okay, 2 more. What's happened to this graph? It's obviously it's flipped in some way. Here are your options. So what we have here is a reflection. Specifically, we've got a reflection in the y-axis. Another way we can think about it is that we multiplied all of the x values by -1. So the thing that you're going to use for this one is -1x inside the bracket. Okay, last one I think. What's happened here? So our graph has gone up from 2,3 to 2,5. This dotted line's gone up from 1 to 3. Here are your options. Have a think about which one it could be. Well, it hasn't multiplied because to get from 3 up to 5, that's different than to get up from 1 up to 3. We've added 2 to the y values. Now, that's outside the bracket, do what it says, the y values. Outside the bracket, do what it says. fx plus 2. I spoke too soon. One last question. So what's happened here? Here's your options. So in this one, our coordinate -1, 2 has gone to -1, -2, and our coordinate 2, -3 has gone to 2, 3. So we have reflected, obviously is one way we could say it, in the x-axis, or we can say we've times by -1 the y values. Now that would have to be outside the bracket, we'd need a minus to make that happen. So it should be our top option here. Okay, so that's the general idea, and again it's all about this outside-inside bracket thing. You maybe have fx notation, you maybe have actual equations. Here are a couple of exam questions. See if you can do them first. We'll unpause and show the answers in 3, 2, 1. So for the first one, we've got y equals fx minus 2. That is an inside the bracket, so it's do the opposite of that, plus 2, to the x values. That means that every point will move 2 to the right. So the lowest point of our graph will now be here. This point where it goes to the x-axis at 1, that will now be at 3, goes through at -3, that will now be at -1. And so our reflected graph, let's draw that a little bit better, will look something like this, or even better. Secondly, we've got to sketch the graph of y equals x cubed plus 8. Now remember, the way you want to approach this is think about the shape, think about the transformation, and then you can put it all together. So this is a cubic graph. We know that a cubic looks like that. The transformation is a +8 outside the bracket. So outside means we do what it says to the y values. And then putting that all together, it's going to move our shape up by 8. So instead of going through at 0, it's going to go through at 8. Okay, a couple more exam questions to consider. So 2 multiple choice ones. We said the graph has been translated by the vector 2, 0. Now we haven't really looked at vectors yet, but the top value is x, the bottom value is y. So we could think about this as +2 to the x values. Inside or outside the bracket? Well, x values, that's inside. So we're down to these two options, and we want to do the opposite of +2, we want to do -2. So we're going to go with x minus 2 all squared. Okay, what about the next one? This curve is reflected in the x-axis. So if we think about reflecting in the x-axis, that means all the x values are going to change. So what's the equation of the reflected curve? Well, it means that instead of x, we'll now have -x. Instead of x here, we'll have -x as well, and we'll have +2. Simplifying that, minus times minus is positive, so we'll have x squared plus 5x plus 2. So it'll be this bottom option here. Okay, here's another exam question. It says this is what y equals x squared looks like, and we want to sketch -x squared plus 2. Now this is one we have to do in 2 stages. We first want to figure out what -x squared looks like. So that, outside the bracket, -1, that's going to be times the y values by -1. That graph, it's also a reflection in the x-axis, would look like this. But then what happens? Then they've got a +2 outside the brackets as well. We're going to +2 to the y values. So what's that going to look like? Well, it's going to move up by 2. So that's our final answer. We have to do it in stages. First do the multiplying, then do the adding, subtracting, just like BIDMAS. Okay, let's get a trig graph in here. Another GCSE question. Here's the graph of sine x. We want to draw 1 plus sine x, and we want to draw sine of x minus 90. Let's do that red one first. What's happened? They've added 1. They've done it outside the bracket, so we need to add 1 to the y values. So 0 would go up to 1, 1 would go up to 2, and so on. You end up with a graph that is 1 higher than the original 1. Curve those together as best you can, and there's our transformed sine graph. What about the second one? Well, this is inside the bracket, so we need to do the opposite. We need to add 90 to the x values. So that means it's going to move to the right by 90. So our 0 point here would move across to 90. Our point here would move across to 180. Our point here would move across as well. So it looks quite similar to start with, and then our point here would move across. So we'll have, once we've moved it, a graph looking like that. And I think you've got to fill in the entire graph so we know it's going to just keep sort of oscillating downwards. So that's our sine of x minus 90. Okay, last question. So this is very definitely a difficult one. It says we've got the graph of y equals x squared minus 1 translated 3 units to the left to give graph A. So it's moved across by 3. And it says we want to write the equation of this graph in the form y equals. So let's think, 3 units to the left. How else could we write that? We could write that as minus 3 to the x values. Now we know x values opposite in bracket. So we know we're going to use x plus 3 in a bracket. But the original equation was x squared minus 1. So it's now going to be x plus 3 squared minus 1. So all we have to do to finish this question off is expand that, and then we'll have it in the form that we need. So this will be x plus 3 times x plus 3 minus 1. That'll be x squared plus 6x plus 9 minus 1. That'll be x squared plus 6x plus 8. So there we go. Our value of b is 6 and our value of c is 8. It's just about substituting that bracket in. Okay, cool.